Okay, so in this question, we are asked to percent of paperboard recycled from a certain town grown exponentially. Okay, use a graphing calculator to fit the data according to an exponential function, and they give you the function y equals ab to the x. All right, and they want to know what a and b are. So I need to make a table. So in decimals, go plus, and then table, and then put in all your values. The years, I always just use the 0. Don't use 1980. So the 0 would be the first year. Okay, 21.5, 10, 27.4, 14, 35.7, 15, 40.1, 16, 40.8, 17, 40.2, 18, 40.9, 19, 44.1, and 20, 49.5. It's funny they missed a bunch of years, but anyway, I've got my data in there, and if I go over here, I can see the data. They say an exponential function, but I guess it's growing, but there's a little bump in there, but yeah, you can say exponential function. So now you want to tell decimals to make a graph that gives you an average of that exponential function. And you use that y equals ab to the x to do that. So we'll do y, but we have to do 1 because that's what's on my table at the top there. So I'm referring to that y value. And then a tilde, so that tells decimals, okay, you got to make something that is similar to that. And then a and times b to the, and then up here I've got to put x1. There we go. So see, the line is sort of an average of the things there. And so what they want to figure out is what A is and what B is. And they tell me to write it to 6 decimal places. Oh, that's a little brutal. Now, I found somebody that did this before, and hopefully this will work for yours. Sometimes the plotting or the modeling, the A, B are just a hair out, but let's try it. Anyway, I only have 4 decimal places. So, but if you go down here and type A in the A, and you can see A, they give it to you to a bunch of decimal places. And I'll do the same for B. Okay, so let me try typing those in and see if they get it right. 19.6164 and B 1.0447. Oh, they want 6 decimal places. What am I doing? 0.44717. And so this one, after that 6.4, I should have 2.3. Oops. Why can't I see what I'm typing there? So at the end of that 2.3. I don't know, I can't edit that. Oh, I couldn't do it down here. Didn't see that. Okay, I'll retype it. 19 point 6 1 6 4 and then 2 3 there. 2 3. Okay, 1 2 3 4 5 6 decimal places. All right, this will tell us if we're right or not. It says no. 1.044717, and the top one 616423. And those are the values that I got there. Did I type all my numbers in right? 27.4, 35.7, 40.1, 40.8, 40.2, 40.9, 44.1. Yeah, all my numbers are right. 0, 10, 14, 15, 16, 17, 18, 19, 20. all my numbers are right. So like I said at the start, sometimes when you do regression like this, the values that they have, doing it with a graphing calculator might be different than decimals. I'm just going to check my answer again a couple times and get it wrong and just see how close they are. Correct answers are 20 and 1.04. Oh, they were close. So they were using a graphing calculator to do the regression, and I'm using decimals, so they might be a little bit out, and the generators for them might be a little out. So try that, but if you get it wrong, let me know and I can mark it right. All right, hopefully that helps you with that regression question. Anyway, that's what I'll be looking for on a test, is something what I got, okay, as opposed to what they got. Okay.